připnout. Introduce ourselves, who we are, and what we're doing, and okay, I need to do this, I guess. Okay, so hopefully you had the curiosity to search on Google or any other search engine what MSD stands for. And if you haven't, well, it stands for Merck Sharp and Dohme, and it's one of the biggest pharmaceutical companies in the world. It has headquarters in every continent, and it handles a lot of medicinal projects, which some of you might use or not. And MSD is called here in Europe and in Asia and in Africa, but in US and Canada it's known as Merck. So please be aware of this actual changes where there are two Merck companies here in Europe. So we are called MSD. So our center here in Prague is one of the three IT hubs in which we have across the world. As I mentioned, one is here in Prague, one is in USA, and one is actually in Singapore. So it's just got started. So we're all part of IT organization, which is widespread across the globe, and we're collaborating in a tight manner on various projects. And our center handles everything from UX design to mobile application development, from marketing to data science and machine learning. So we handle various projects, we handle various IT-related problems across the business, and we go across domains. So we have the opportunity to collaborate in many fields and in many problems. So what drove us to, or let's us first introduce ourselves.
Okay, I'm Zikeš. I'm a software developer focused on machine learning. You can find me on Twitter or on GitHub under this handle.
And I'm Stefan Negru. I'm a semantic knowledge engineer here in MSD, and you can find me anywhere with the handle blank dots, which is a pun. Anyway, so what drove us to healthcare and, come on. What is the biggest trend here in IT and across pharma nowadays? Well, it's personalized healthcare. And what does personalized healthcare mean? It means providing to patients personalized leaflets, personalized information, personalized medicine, personalized everything. And it's one of the biggest trends which is handled both in IT and in pharma. So it's one of the biggest problems which we are trying to focus on. It drives us to explore new products, new ways of working, and explore new possibilities in our field. And one of the ideas of this is like, how do you process all the amounts of data you get from various sources, from mobile devices, from different websites you're browsing, from different kind of information across the globe and in your personal space or in a patient's personal space. And it's all about data, from data privacy, from data quality, from any kind of problems related to data. We're handling these problems and in various ways. One of the biggest issues you might be aware of is data privacy, because we don't want to expose unnecessary information to public or to expose patient-related information, private information. But also the problem of data quality, because most of the data out there, it's unstructured, unfiltered, and it has a lot of issues. And we're handling all these problems as we go along. And going to, from this data revolution, as we call it, which comes from IT industries or across all industries, and pharma is the latest one to join this kind of data revolution, where they want to make sense of the data they're getting from either from internal data sources or from external data sources, and they want to explore the possibilities around it. And in our center, we're handling this across teams, across our groups. And we're going from information sciences, the data analytics groups, to advanced technologies, and even big data platform, and even scientific information management, and other groups. And we go about this, something we like to call data-driven approach, where we take insights from data and apply it in our everyday work and the way we work. We call it data-driven / any buzzword, analytics, design, machine learning, and so forth. And one of the use cases we're going to present today takes in mind this approach. And consider that we're looking into various data sources and way to interact with these data and get most out of it. And Hansa is going to tell you more about it.
about like our first use case that we are working on in Prague, because as Stefan said, we are pretty new center, so we are just getting to different projects, and this is like the first we started to work on, and it's kind of company internal expert finder. This company internal expert finder is based on it should be kind of automatic. We don't want to force people to insert information. So it's kind of complex project that contains machine learning parts. Our advanced solutions or emerging platforms team work on like whole product from actually implementing databases, front end, everything. But we, especially me, Stefan, and Andre, who is sitting in here, we were working on machine learning for this. And also we were combining this with linked data and ontologies. As I said today, I will say about expert finder, and yeah, as you can read, it's a combination of NLP. First, let's define what's expert. I guess that everybody knows this video about what's expert. So how the system works, we are trying to find expert, and then in corporation it can happen that you end up somewhere like this, but we hope that people in our company use it in a better way. But I guess if you don't know this video, you should have a look at it. It's funny and okay, yeah. Okay, so now I will describe how does it work. We are a pretty big company. We've got all around the world. We've got, based on Wikipedia, 74,000 people. We've got several internal content management systems in that company. And to take you more like inside our problem, we are treating all as a graph. We have kind of company graph, and in that graph we've got employees, and in that graph we've got also content items, which are most of the time textual content items. But the problem in our company is that employees are from various domains. It's not just computer scientists, not just scientists who actually make drugs. It's various kinds of people, salespeople. So this is kind of problematic for us. Then we've got some kind of, we are measuring interactions of people and content items. So basically we've got for every user we measure, for example, when he created some content in our internal company system, when he read some content, or when he edited some content. And we've got some lame small data set that is, let's say, supervised, that people are trying to tag sites that they just wrote or that they just edited, but it doesn't work well for us right now. Here's once again how everything works, like from the architectural point of view. You can see we've got some kind of data streams. This is like those actions, like interactions between people and our content items in content management systems. And data goes to graph, where in graph it updates. We call it energies. It's some kind of score, like how much is related the person to given content item. And then it goes to just plain full text search engine that we use to index all the content items, and there is some kind of machine learning part of the whole project. We've got several APIs there for rest of the company to be able to use it, and we've got front-end application for employees to be able to use it like in comfortable way. Yeah.
Okay, so Hansa was telling you about this graph, this awesome graph. So what is it about? If you are familiar with the concept of knowledge graph, or what search engines call a knowledge graph, or what Google introduced to be a knowledge graph, It's something like a knowledge base of facts which are from various sources. And these facts are structured in some way, be it hierarchical, be it like a distributed graph. And we're applying the same principle to enrich the knowledge we have in our graph, because we want it to be easily accessible, we want it to be structured, and we want it to have some control over the concepts or the sources or the topics that are reflected in that graph. So besides the content items and the persons who are all reflected in that graph, there's some sort of part which is called concept model or some sort of knowledge base model, which contains some internal taxonomies and some external taxonomies. The reason we want to do that, I'm going to get to it in one moment, is we want to provide some structure into how the topics are clustered, how the topics relate to one another, and to better categorize content. So if you're familiar with some of the linked data principles and what the taxonomy is, like basically hierarchical structure, what you would see in a website, you'll have like pages under other pages and so forth. So it'll be like parent-child relationships. We have this kind of structure in the graph in our concept model. It's here you cannot see because actually the lines are not easily be saw, but you can go to this link and see how a taxonomy would look like. And this one is actually a really good one from nature. And we have this structure, as I was saying, in our graph, where we have different kind of topics. So here you'll also have content items, persons, organizations, and different kinds of nodes, which are all clustered into this graph. And those content items will actually will have some connection with these topics. And these topics are actually described in the graph by some sort of keywords. And those keywords can be either to one topic or to two topics or to more topics, in order to properly describe what a topic would look like. Be it like IT topic, bio topic, or any kind of pharma topic, we will have them in the graph. And these areas of interest represent what the content is about. So some people might talk on IT and pharma-related content, and we have some connections, and we can drive some connections between these topics and the persons who are interacting with those content items, because we know what the content items are about by these keywords. And Honza will explain a bit more how we extract those keywords. And knowing this, we can actually do some inferencing on the graph and know more about how people cluster into topics, how content clusters into topics, and these kinds of information. And I guess you go here. And this is a practical application of this.
Okay, so I'll maybe go one slide back for a while as well. Oh. Yeah. Okay, so let's say that at the beginning we had just the graph, and we were trying to manually add there some topics to the graph. Like we had the design of the graph was that we had content items, people, and those content items were related to those topics or keywords. And like doing this all manually isn't that smart, or it's possible to do it, but it would take a long time. So we have deployed a thing that's called like keyword extraction service or topic extraction service that was trying to get this topic from the content items automatically. And we have leveraged the graph and a little bit redesigned the whole expert finder system. So I can show here how does it work. So we have basically two use cases. First use case is when you just query some word, like for example Python here, and you need to get who are the experts in the company who can help you with that. So you query Python. In our new system, in our latest system, it goes to full text search engine. And we got some content items with highest relevancy, and those content items with highest relevancy goes to graph, and then is performed computation on top of energies that we store in graph, and on top of relevancy of the search result. And based on this, we get experts. Basically, for Python, you get content items, and those content items has relations to to our employees, and we sum it up, and we get experts.
Give an example of what content items there are?
Yeah, actually, content items in our case is mostly text. For example, someone wrote, for example, one of our drugs is called Januvia. So someone wrote something that he find out that Januvia works better than some drug from competitor, and then it's like one content item. And in the search engine, this one would get like very important for Januvia, for the drug. And also there can be also other content items. We have there can be images, but right now we are not treating images in any special way. We don't have any algorithms to get content out of images. We just use captions and just textual data. But in future, maybe we can leverage this images information or videos information, or we can.
Where do you store content items? Do you store them in a separate graph database or in a separate?
Currently, we store them in our content management system, but we are replicating them to our graph database. So we store them twice right now. So this is the one way of expert finder, and second problem we need to. Oh, what? Too fast. Okay. Seems like. Okay, so the second and more complicated way or problem for us is that we basically need to find when you need to find expertise for a given person. Again, we would like to have it automatically. We don't want to force our employees to put there what they are experts on, and we are trying to find their expertise based on what they are. How they are interacting with our content items and with our content management systems. So basically how it works is it has two branches. First one is that we are periodically retraining model. We've got some kind of, we have all the content items stored in full text search engine. And we've got set of skills. We actually started manually with this set of skills, and now we have kind of feedback loop for it. So from these two things, we are querying label data, and based on this label data, we train classifier. We retrain it. I think originally it was once a week. Now we retrain it once a day. And there we were experimenting with standard classification and with keyword extraction that was based on some kind of open source software called MAUI. But currently there is deployed linear SVM for the classification. And when actually someone types a query, for example, John Doe, then it goes first to graph. And from graph, we query all the content items that are the most relevant for the person, based on the energies that are stored in the graph. And then all the content items goes to the classifier, and we get from the classifier we get the most important labels for the given word. We can do also topics, but right now we are more interested in the expert finder. We are more interested in human readable keywords. LDA topic wouldn't be nice if you would give to people that he is expert on LDA topic 62, unsupervised way. That wouldn't help much. So right now it's classification to words, and from this. We are able to infer the expertise. So basically we are able to list for all the people based on their interactions with the system what they are experts on. What are kind of challenges in our system is, as I said, that we have different domains across content management systems. We have different problems like disambiguation between different terms. For example, for us, EMR might be electrical medical record or elastic map reduce for some teams, or API has two different meanings as well. It's not just the programmatic API. What was the meaning of the second one? Active pharmaceutical ingredients. So yeah, this is the problem we are facing. So we are trying to treat this as the link data problem or semantic web problem, but rest of this we are trying to treat as a machine learning problem, because we don't need to manually create ontologies and we can do it in an automatic way. Yeah, Stefan can.
Okay, I'll plug here. So, Hamza was telling you something about, or I'm coming back to the graph. So, Hamza was telling you something about we have some sort of energy calculation in the graph where we compute based on how people interact with content items. If they create it, view it, read it, or do something with it, we compute some sort of energy. Think of it like some sort of PageRank algorithm. We reflect this in the graph. There's some sort of number out there, and based on this number, and based on other features we got in the graph, we're trying to do some recommendations. Why is this useful? So considering the size of the company and consider the spread, expert finder will be relevant if you want to find someone who is closest to you and has some sort of expertise, and that could help you with, I don't know, APIs, but those kind of APIs which you are interested in. And you might want to find similar persons with your expertise in Python or in other areas. And we are doing this kind of recommendations right now. We're fiddling around different kind of models, different kind of computations. We're trying to combine graph topic and content recommendations into something that actually makes sense. And we're exploring different kind of algorithms. We got some initial results. We're not that happy, but we're trying to improve them. So you can think of them like some sort of social network recommendations, where you can find persons similar to you in your area or experts in your area. But these are not the only kind of recommendations we're trying to do, like content which you have not previously visited that you might be interested in based on what your network is doing on that content item and so forth. So we're exploring like other areas where this data which we clustered so far and this whole approach which we explored so far would help us. And yes, and these are some of them. Sorry, microphone. Okay.
So I'll tell you something more about other projects, like briefly in our center. So this was Expert Finder was just the first use case that we started to work on, and many more projects are coming in. Big thing in our company is starting to be medical devices data analysis. We've got like several projects that are starting on this, but unfortunately there is kind of problem with data privacy on many of projects from this domain. We can use it for clinical trials. I don't know if you are aware of what clinical trial is. It's kind of when you develop a drug, you need to go through several stages of trials, and it's like most of the drugs during the development just fails during those trials. So we are trying to improve this ratio, to improve number of successfully developed drugs from those that where the development has started. Then we have a big field that's chemistry-focused machine learning. Here is some research going on right now. We are trying to, because till now in pharma it was mostly that people were trying just different chemical compounds and they were trying what's gonna happen, and they were just driving their decision by their intuition. And in the last few years, people started to use things like machine learning, like data-driven approaches for this. And it's basically it's starting right now. So there were some guys from our information technology group. They tried some kind of correlations between actual clinical trials and some features in chemical from the chemical analysis of the compounds. Then we are starting to work on something also genetic data related, and various searches through literature. That's we got a lot of literature that's only company related or inside company, a lot of like description of chemical compounds, a lot of descriptions of drugs, and we are trying to do some literature searches. And actually, the one thing that I can say now, what I'm starting to work on is kind of combination of deep learning in those two areas, like genetic data related and literature search. We are playing with stuff like Word2Vec or this kind of stuff. We don't have any results yet, so this is the reason why I'm not presenting this stuff right now. But we are trying to treat it and see how it's gonna work, and yeah, I think it's a big area, and I kind of believe that it can work and it can help us to move forward. Yeah, basically this is everything from us today. If you have any questions or if you would like to know more, just feel free to ask. We are currently using Neo4j.
We played around other engines, Neo4j stuck. What's the name again?
It's Neo4j. We are using Elasticsearch, but I guess if we would use SOAR or something like that, it would be quite similar.
Do you use some form of methodology?
Yes.
And is there some methodology which is generally accepted, like friend of a friend methodology?
So we're not using FOF in there yet. We're using parts of it. So the graph, even though it's, so there's a difference between what you're saying and the Neo4j graph, because Neo4j graph, you have to specify your own, it's a property graph model, and you have to specify your own semantics and your own sort of schema-like relationships between the nodes. So we are reusing properties from an ontology, and it's formally structured. It has a formal ontology behind it. And it's mostly reusing concepts from different ontologies and stuck into one. So
Is there some methodology in the field of medicine which is generally accepted?
So there are several which are generally accepted, depends on the domain which you're looking for. So I know the most stood out there, it's gene ontology, but that's because it's used widely in integrations of various sources. For example, if you look into one of the biggest open source projects out there, which is OpenFacts, it uses it for doing some alignment with data sources. If you know OpenFacts clusters a lot of open source data, but the advantage stands that in fact that it does align within them, so it doesn't have any inconsistencies, because just putting ontologies into all in one there together, you'll not be able to compute anything on it. It's undecidable. So it has some proprietary work in that. I cannot say more on that because it's proprietary work. So there is gene ontology, which is general access, but there's also bioassay. There's also, depending on the domain, you'll look for various sources. So it depends.
Do you collect data directly from doctors?
I'm not sure about that. So some projects, I would say yes, but depends. If it's electronic health records, there are some regulations on that depending on the country. So I cannot say precise yes or no. So depends on the country.
Highly regulated industry, so
It depends on the country.
quite.
I know doctor is the best source of information, and usually it's not structured because pharmaceutical doesn't support it.
Yeah, actually,
So I can answer more on that. There's the electronic health records. There are some standards out there, like the HL7 standard, the FIRE HL7, which is a new standard for structuring electronic health records. So there are some practitioners and there are some countries which already implemented that standard. There are some countries who already did their own structure and using XML and so forth. So it depends on from country to country. Some structure, some don't. There are countries out there which have really good structured data.
Yeah, we have Daspa, which is our Czech standard.
So yeah, so
But it's not used very well.
yeah, so but you're right. Some like have free text, and this is one of the problems I think you're working on.
yeah, like we would be very interested in like plain text, like information from EMR right now, but we are not able to get to it, get the information because it's like really sensitive and yeah, no one wants to provide it. Or I think even if it is in our company, we don't have access rights to it.
It has to be
So,
analyzed, it has to be gone
yeah.
through several processes before we actually
Yeah,
can get to
it's
it.
really problematic, and I'm not sure if we've got the data. There is also another problem that we've got. I think it's related to this EMR. That, for example, my doctor, she writes always by her hand. So this would have to be OCR, going through some OCR system. So yeah, this can be another problem. We've got this problem also in some kind of our, as I was speaking about literature search, in some our old papers, they are also like handwritten. So this is really problematic.
I understand how you will find people who have written a lot about Python, but how do you judge the level of expertise in a given topic?
We've got basically it's based on energy that's in graph, and every action that the person has some interaction with the content item, energy increase. It's different increase for editing, for creating, for reading, and we just compute some of these energies for the most relevant content items, and we multiply it by some relevancy from the classifier, or it can be probability in our case, and we just sort those people.
I understand this is classical like and I understand that by this we will capture the people that created most of the documents. These might not be the experts.
Yeah.
So, I mean, the person who writes the most might not be the best expert.
Yeah.
So what I'm asking is whether somewhere in the taxonomies or ontologies or somewhere there is a hidden mechanism how you will judge how you can judge the level of expertise of the person.
We currently don't do.
If someone writes a very detailed, specific explanation of the implementation of one library in Python, you might be actually much better expert than someone who just copy-pasted all
Yeah.
from the website.
Yeah, that's true. That's the thing that sometimes happens to us, that our system doesn't work well for people who don't write almost anything at all, or who wrote just few articles. It doesn't work well for them. Generally, when we see the system, it works quite well. It seems like in our company, or at least it doesn't work in a way. It was in a way that it is in a way that you can find like the manager of the Python developers team or something like that, who can point to you, and it's quite a big help in like 74,000 people company when you can when you can reach Python developers. But you are right that we are currently not treating this stuff. We were experimenting with something with like structuring taxonomy, like when you query people for programming, you get like Python and different languages under this. We are experimenting with this, but we realized that maybe for our company, like no taxonomy at all works better. It's like strange, but
So we're just plain taxonomy, like 1 or 2 levels deep. So it depends. Those energies actually decrease over time, so you might know. But we're also thinking of like because some content might be like just few words, some content might be just like bigger in quantity and bigger in importance. So we were also thinking of experimenting with some sort of content quality measure. And this is one aspect we were thinking of. I'm not sure we're exploring it right now, but yeah. Okay, so depending on the size of the content, that we were thinking also on that, but
somehow related in CF-IDF representation of text. If it would be just plain bag of words, then of course if you write some page which is like real long, you would get like just in lot of Python matches. But if you have CF-IDF, then it's like related, so it's like weighted, so it's more reflected in this, I think, this quality thing.
One thing we forgot to mention, we have some sort of feedback looping process. So we actually, because we want to improve our system, we say every time we ask users, do you think this person, or do you consider yourself an expert on this? Because we looked at how LinkedIn does it, and we're not sure if this is the perfect model, like just selecting and asking people +1s. But we are taking those approaches into consideration, like, do you think this person is an expert on Python or whatever? And we feed it back into the model and say, we are going to improve this by this percentage based on the responses we have. So, yeah. So we have some sort of measure of improving it, because it's not perfect 100%.
You keep track of changes, historical changes and energies for a particular person? Something in the last year, this person, their energy for Python increased or decreased?
Actually, the graph isn't there that long time, I guess. Last year we don't have like 1 year right now.
So
I think it's
some historical.
yeah, we can basically replay all the graph if you would like to, and so we can replay it to the given date. So we store historical data, but it's we've noticed that we had like some problems, like for some people that, for example, someone went for vacation and we realized that after he came back after long vacation, he wasn't expert at anything. So we had so it might be the case a bit, but I think not that much. So yeah.
So don't go on vacation.
Yeah.
I'm not sure if I understood it right, but at the energy level, the energy level changes for various sections, are these determined, or is that something that's determined by the machine learning classifier?
Basically, we use mostly heuristics for this, for determining energies. We are thinking of some machine learning, of some like self-learning system, but I think heuristics works pretty well. So
do you have some kind of, what kind of machine do you use to evaluate how well your system actually works?
we have several like evaluation mechanisms. We are evaluating this partially like the classifier based on its own. Then we try to evaluate this on some kind of validation data set, let's call it like this, but it's quite subjective. It's true that we went like in our team several people through it, and we had like different opinions on this. So I think in the case of expert finder, you can't never be like 100% accurate because everybody has different opinion. But at least we can see there that it works. It works in a way that it looks kind of good. So yeah.
People are using it. That's
Yeah,
our
yeah.
measure. Actually, I know they're using it more than people search.
I know it was discriminating Stefan quite a lot
Yes.
for a long time. It was
This
just
system is like in your corporation and used widely.
while it's used mostly here in Prague in our Global Innovation Center. We are trying to promote it further, but
But Stefan was saying today that they're using it more than people search. So because the results.
It has, I don't know if it is because of the user interface or, but it has maybe better results.
Yeah.
So is there a paper published or some technical report or something about details, or it's just
So it took us a month or two to get over this process to have this presentation. Probably, I don't know.
It's kind of problematic. We are like, how we are like pharma company and we are regulated on a lot of stuff. And problem is that also like things that aren't our core business are regulated as well, like side effect. So unfortunately not yet. We hope that it might get easier in like short future, and I think like Prague Innovation Center is kind of doing a really good job and trying to destroy all this like regulation when they are not possible, when they are not needed, like or accurate. For example, when you have some drug, you can't give it out because you would lose a lot of money, and even in the US, it's like really regulated. It was identified like one industry that has to be regulated. I think it was after 9/11 or something like that. So yeah, so it's kind of problematic.
But we're slowly getting there.
Do you have a problem or is there important of language? You mentioned content, you have a worldwide company, so some articles can be in different languages, or is everything in English?
Like our corporate policy or in our company, we are trying to have everything in English. We are not happy, or even managers or those like other people are not happy if there is something, for example, in Czech, Spanish, or in other languages. But we have realized that we have some content items that are in other languages. We are trying to improve classifier by just filtering everything out. Just focusing only on English. Everything else we are just throwing away. You mean like two different languages?
Yeah, I mean like
I think content that's not in English, it's really minority in our company. It's like we are trying to force people to write in English because we need information to be reusable and like traceable by like management that's in the US. So yeah.
Or just basic statistics, think of it like 10 or 15% of the search terms we saw or search content we saw in the company where I saw are basically in other languages, rest is English. Less than 10%.
1 or 2%.
Yes. So you consider relevancy of that. Like you need to focus your efforts on. But it'll be interesting. So depending on the country, we might underneath or other videos we might end up doing. So in case of Python programmers, I don't think they are using the word Python that often themselves. So how do you handle that? I mean, in the biomed domain it's probably not so bad, but in other domains,
I think
we're also searching for different kinds of keywords in text which reflect libraries associated with Python or some sort of libraries.
But we are playing with that, but at the end we realized that even Python programmers are writing about Python quite a lot. We are like surprised as well, but we need to do like most of the time like documentation, like in this content management system, to describe in which language it was written and what kind of libraries are used there, and like simply do the basic documentation. And most of the time there is like written that it's written in Python. So maybe this is the reason why it works quite well, or at least I remember that pretty recently I was like the #1 in Python. So no, just yeah.
The title of the lecture is NLP and something. So what kind of NLP technologies are you using? Because I haven't.
Yeah, it's basically from NLP, or from my point of view, it's like the NLP has like two parts. One is like statistical or machine learning based NLP, and in this presentation there is like only a system that is like focused on the statistical machine learning. It's text classification. I consider this being NLP, and also topic modeling. We use like LDAs in this, so as we have described the topics there, it's also, from my point of view, it's like NLP.
And also you were mentioning keyword extraction service.
Yeah, and keyword extraction service. We have their service where we are trying to extract keywords from.
What kind of technologies are you using?
Actually, it's kind of mix. I am using Python the most, but there are some components that are in Java, and I think something is in C++, I guess.
The service, maybe.
Yeah. But most of the time, I use Jensen because I'm used to work with this. It's from Radim Řehůřek framework, one open source framework. I use scikit-learn for classification in those services, and I know that
For the keyword extraction service, we're using some sort of open framework which is called MAUI Indexer. It's quite good. It allows us to plug in the score taxonomies and better refine and train the models around it. So we were training it like quite a lot, and we improved it quite a lot since the beginning of the year, and we got good results even without any taxonomy in there. So yeah.
But maybe the biggest problem in this was for us that in the MAUI it's like a pretty complex tool, so we wasn't able to see exactly what's going on under our hands. So using just the plain classification in scikit or this kind of stuff has shown us like insights, like to see. Because I think in machine learning, most important is to have a look at data and to always validate that you don't have somewhere some crap. When you feed a classifier with crap, you get crap at the end. So we have like several like parallel systems. Some we use for just validation that that everything is all right, and some we use like in the tool. We haven't tried that. It would be maybe nice thing to do.
Every person who joins the company has a profile which stood for his bio. The problem is some haven't updated. So, but it's a good idea. Like we might end up proposing it. Although the adoption, I'm not sure about it.
I think we would have to do it in some guerrilla way, but
Yeah. Right. If there are no more questions at this moment, I'd like to.
maybe I've seen one more question.
Oh, is there? Okay. So, if I may, my last question would be about the consumer input. Do you intend to use kind of a limited set of some choices, like Python or something, or pass some really complex question like I need to research on graph X that contains X and Epsilon and is developed by blah, blah, blah.
Currently in the expert finder, we have limited set of skills, or at least in the like reversed expert finder, when you are trying to search expertise for the given person, you can search for everything that's based on like that you can full text search. So you can try to do any full text query, but it doesn't work well for those that are not reflected there much. But you remind me one project that was going on in literature search. We are trying to do this for scientific literature, to find like literature based on this like sophisticated queries. More like you need to get papers about clinical trials that were that were performed for people that are under 26 or from 22 to 26 with this and this disease. So there are attempts to do this in this domain, but not in the expert finder domain.